With warfare technology taking giant steps forward during the last few decades, it has become increasingly difficult to deal with air threats that target ground forces or fortified areas. From mortar strikes, artillery barrages, and drone strikes to helicopters, aircraft, and precision-guided missiles, there's a specific countermeasure for each of them. Still, they do not come cheap, and more often than not, a combination of these elements is needed, but they're not always simultaneously available. In 2021, German company Rheinmetall released footage showing a state-of-the-art defensive system taking down swarm drones and unmanned aerial vehicles with pinpoint accuracy due to perfectly autonomous and synchronized systems. It is called the Skynex Air Defense System, and it appears to be the solution to connecting a wide array of systems within a larger framework that could potentially shield against all sorts of air threats. While the use of artillery was already prominent in Europe going back to the 16th century, larger and more powerful artillery pieces were eventually developed, allowing engineers to obliterate enemy forces with a never-before-seen level of carnage. However, with the outbreak of World War I, artillery became 10 times more devastating with the coordination of air attacks, which displayed an unprecedented development in military technology. Furthermore, bombing raids proved that air attacks were more than feasible to deal a more decisive blow to the enemy. When World War II finally broke out in 1939, the devastation brought by air attacks became even more powerful and effective, with fighter aircraft, massive bombers, and the V-2 rocket creating a previously unseen level of destruction. Then, in the 21st century, air attacks dramatically changed, with the wars in Iraq, Afghanistan, and the Middle East seeing the rise of unmanned aerial vehicles, or UAVs. These drones do not just serve as scouting aircraft for gathering intelligence about the enemy, but also as attack aircraft, carrying bombs or coordinating the launch of missiles from a remote location. They join other air threats, such as helicopters, fixed-wing aircraft, drones, artillery, mortars, and precision-guided rockets. Such a vast array of arsenal gives militaries worldwide the capacity to uninterruptedly attack an enemy without the need to consider the bad weather, poor visibility, or terrain. According to most experts, the main trends in air attacks for the following years will increase the accuracy and saturation of strikes by drones under all weather circumstances. This, coupled with the extensive use of electronic countermeasures, is forcing the militaries to be better prepared with the latest air defense systems. However, there already are specific countermeasures to the many types of air assets ready to wreak havoc at any moment, and they do not come cheap. But German company Rheinmetall seems to have found an innovative solution to develop a one-for-all ground-based air defense system called Skynex that could revolutionize air warfare. Unveiled during Eurosatory 2016, Rheinmetall's latest project has come a long way to show its true potential as the ultimate defensive system against all sorts of air attacks. Eurosatory is an international weaponry industry trade affair held in the Villepinte Exhibition Center in Paris every 2 years and is organized by Cogis Events in partnership with the French Ministry of Defense. Several companies present their latest military technology during the exhibition, whether from the land, air, or sea industries, or as operating systems that cover them all. Although the exhibition is only reserved for military personnel and professionals from the industry, Eurosatory has managed to keep a steady flow of visitors throughout the years. And during its 2016 edition, over 1,500 exhibitors from 57 countries presented their gadgets to more than 300 journalists and 56,000 visitors from 140 countries. It was during this impressive exhibition that Rheinmetall unveiled its latest craft, the Skynex Air Defense System, setting a new standard in the field thanks to its unique level of open architecture and compatibility with other systems. Down to its basics, Skynex is a fully networked, next-generation ground-based air defense system that should be able to destroy every air threat that can be thrown at it, be it mortars, artillery shells, rockets, or swarms of drones. In addition, it can be configured to defend critical infrastructure or airspace with what the company has described as maximum economy of force. According to the company's product description, the Skymaster command and control system forms the core of the overall system, and Rheinmetall has explained that it comprises, quote, various sensors and effectors that can be linked in a modular way in order to fit mission requirements. This results in an authentic, automated system of systems that can be centralized and decentralized based on the user's decision, and its nerve center can connect with multiple subsystems to dramatically bolster its performance. Finally, another essential element of the Skynex system is the XTAR 3D Tactical Acquisition Radar. This three-dimensional tactical acquisition radar works in X-band and can perform functions such as, quote, short-range search, detection, acquisition, tracking, classification, and identification of air targets in order to supply a three-dimensional local air picture to command and control network, as well as track and threat data for queuing of fire control systems. XTAR 3D was tailored to keep its excellent performance against several threats, including UAVs, cruise missiles, rockets, mortars, helicopters, and fixed-wing aircraft. Up to 3 Oerlikon XTAR 3D search radars and 12 guns can be set up through Skynex's system, and its excellent compatibility allows for many different configurations. However, the system's basic setup is only the starting point to expand Skynex's arsenal, and it comprises the command and control package, a sensor package, and a shooter package. The control node houses the Skymaster interface. From it, the radars and 4 potent Oerlikon revolver guns Mk3 can be remotely controlled from a distance. One revolver can fire up to 1,000 rounds per minute with devastating effects, and coupled with the other 3 guns, the system really proves that it can handle multiple targets at once. Each unmanned Mk3 gun has its own sensor package that includes radar, IR camera, and laser rangefinders that make the weapon extremely accurate and effective against any air threat. With these unique assets, the gun can engage any target assigned by Skymaster at up to 4 kilometers. Furthermore, the programmable 35mm ahead ammunition allows the revolver gun to destroy even the smallest of targets, including conventional drones available in the civilian market. Meanwhile, tracking and engagement are calculated automatically by the integrated fire control processor. Without the need for additional setups, these all-weather Mk3 revolver guns have no equal in the current market. During the 2021 Air Defense Systems group event organized by Rheinmetall, the company showcased the power of the Skynex Air Defense System with a truck-mounted configuration that featured a single revolver gun Mk3. Footage from the event shows how a swarm of small white drones makes its way through a green valley, looking for its target. Flying in formation, but keeping enough distance to disperse hostile fire, the swarm then inspects the ambiance without issues until it's detected by Skynex. Subsequently, the revolver gun Mk3 powers up and allows Skymaster to select the target. Once the hostile swarm drones are appropriately identified, an operator monitoring the defensive system is seen giving the green light to destroy the targets. Also, the camera feed, the radar, and the targeting screen are clearly visible on the screen when the operator pushes the buttons to activate the gun. Almost instantly, a devastating barrage fired from the Mk3 pulverizes the entire drone formation with impressive accuracy and ammunition economy. Another effective defensive asset tried with the Skynex system is the twin-gun GDF-009 Trio, which is also remotely controlled and can engage targets by itself through its integrated sensor unit that provides automated tracking using flexible target designation with 2D and 3D search radar. The device is transported with its own trailer undercarriage, making transportation and deployment on the battlefield easier. The twin-gun GDF-009 Trio was showcased by the company in August of 2020, when it took down several UAVs with several barrages that got rid of them in only a few seconds. Once again, the Skynex system proved how the automated targeting system has an excellent accuracy that not only saves ammunition, but valuable time during firefights. Rheinmetall recently closed a partnership with Italian company Elettronica to develop a highly advanced electronic warfare countermeasure suite that will be able to swiftly get rid of shelf drones weaponized by terrorist organizations. This effector suite will include GPS, communication, and radar band jammers to disrupt hostile unmanned devices. Additionally, the Italian company is also working on making its system fully compatible with existing Skynex configurations without modifying the control node. Rheinmetall is also looking forward to integrating Skynex into more advanced systems, such as a battalion layer control node or higher air defense command centers, to provide an authentic layered air defense architecture. Besides the Mk3 guns, Rheinmetall is also testing its own Oerlikon laser gun. This effector is armed with laser modules that superimpose their beam onto the target, and its effectiveness can increase if complemented with more than 2 laser guns. Lastly, the company is also testing an RAM missile designed specifically for countering hard-case targets, such as large-caliber artillery shells and precision-guided munitions. This missile has been dubbed Cheetah, and it perfectly complements the already devastating arsenal of the system. Following its cost-effectiveness guidelines, the missile is designed to only engage targets with a pre-calculated point of impact within the protected area. Rheinmetall promises plenty of innovations in the following years, and the German company is already hard at work, bringing more features to make the Skynex system more effective. The recent surge in cheap and easy-to-fly drones has dramatically changed the world over the past few years. From photography to agriculture to disaster relief, and even on the battlefield, easy access to a remote-controlled flying device to monitor crops, take stunning pictures, or deliver vital supplies to hurricane victims has proven a formidable accomplishment. Even so, the technology can also be used for nefarious deeds. With the increased availability of low-cost drones, private property breaches, espionage, contraband smuggling, and even lethal attacks have risen dramatically. Nevertheless, a group of English engineers has made it their mission to tackle the growing problem, and have developed a net-launching anti-drone bazooka named SkyWall 100. The idea is to counter the ubiquitous nature of modern drones with another technology that is low-cost and highly mobile. And in contrast to other drone neutralizing weapons, the SkyWall does not destroy the drones, it captures them. If the development process continues as intended, the net-launching bazooka has the potential to become a crucial asset for military defense and civil security. In 2015, a drunk U.S. government employee decided to fly his DJI Phantom novelty drone around the White House. The man launched the vehicle from his apartment building close to the executive mansion. Suddenly, he lost control of the aircraft that then fell inside the White House grounds. The reckless worker had no ill intentions, and the drone did not pose a significant threat to White House personnel. Even so, the incident led to a rigorous investigation, and the results were alarming for the Secret Service. It turned out that the drone had not been detected by the numerous White House security systems. Moreover, their central radar system, which is designed to detect larger aircraft, did not identify the drone. The harmless event led to the realization that even the most fortified complexes on Earth were weakly prepared to deal with the intrusion of small-sized drones. If the invading drone had been armed with explosives or chemical weapons, it could have theoretically become a national security issue, one that could put the leader of the free world's life in jeopardy. And it's not only the head of state that has to worry about the threat posed by widespread low-cost drones. Going back to 2010, drone contraband delivery to U.S. prisons has become rampant. On August 26, 2019, 2 men were apprehended in Georgia, merely 100 yards away from Telfair State Prison. In their car, they found a 1.9-pound Storm Drone 4, a radio link UAS controller, a Spectrum video monitor with a headset, 75 grams of loose tobacco, several rounds of ammunition, and 14 cell phones. The incident showcased how drone technology can be used to launch severe security threats even with very few resources, but also put the spotlight on how unprepared many secure facilities are to deal with the issue. As such, several companies have raced to find a solution to the drone problem, especially as the technology has become cheaper, faster, and capable of carrying more weight. Many methods and devices have been developed to address the vulnerabilities of drone infiltrations, but it has been a hit-and-miss process. Many solutions have led to additional problems, while others were way too costly for comprehensive implementation. One of the technologies that have become increasingly popular in dealing with drones, especially during high-profile events, is radio frequency analyzers. The devices have an antenna capable of detecting the signals between a drone and its operator, and even deciphering the brand and MAC addresses of the specific drone. The information is then used for legal prosecution purposes. However, radio frequency analyzers become ineffective in areas with too much radio activity and cannot detect autonomous drones. Another way to monitor drone use is with acoustic sensors and cameras. Nevertheless, the specialized microphones become useless during noisy events, and cameras are famously unreliable in low-light conditions. In reality, military and law enforcement facilities can afford more complex drone defense systems. High-power microwave devices, radio frequency jammers, and GPS spoofers are highly effective at disabling and stopping drones in their tracks. However, they often disable other nearby technology and can cause collateral damage if a disabled drone falls into innocent bystanders. Radars are a formidable detection solution, but they are expensive, must be specially designed to detect small objects, and often cannot differentiate between drones and birds. More experimental methods include high-energy weapons and even birds of prey. Both are very effective, but energy weapons are incredibly costly and pose an increased risk of collateral damage. And while birds of prey can intercept and capture drones, there's always a limited amount of trained birds that can do the job. In a revolutionary attempt to make the taking down of drones cheaper, safer, and less disruptive, the English company OpenWorks Engineering has designed an innovative solution that takes unauthorized drones out of the sky and brings them down safely for further analysis. As an over-the-shoulder launcher that resembles a bazooka, the SkyWall 100 is a compressed air-powered gun that launches a projectile fitted with an expandable net. The technology is designed to capture a drone in mid-flight and then bring it down safely using an integrated parachute. Its features make the SkyWall a highly safe solution that not only keeps crowds or bystanders safe from debris, but also allows the security team to retrieve the drone for subsequent investigations and legal prosecution. The weapon's computer-aided scope can lock on to a flying drone and accurately calculate the aircraft's current speed, angle, and trajectory, allowing the operator to launch the net not where the drone is, but where it will be at the time of contact. Moreover, the system is a low-cost alternative to other expensive solutions like radio jammers or microwave devices. Plus, it can also be implemented into an already operational radio frequency analyzer or radar system to create an extensive defensive network over a specific perimeter. What's more, for facilities with a constrained budget of temporary defensive perimeters, the SkyWall can work on its own, making it an extremely versatile solution. During its initial testing, the SkyWall proved highly reliable and safe with a phenomenal drone capture rate. Even when the system misses, the technology is designed to guarantee the safety of anyone around by deploying a parachute and bringing the projectile smoothly into the ground, where it can be reassembled for continued use. Only a single operator is needed to deploy the SkyWall 100, and the technology is intuitive and easy to use, allowing any security agent to quickly learn its operation and maintenance. Additionally, the weapon can be reloaded in less than 8 seconds, allowing a security team to neutralize the threat of even a swarm of drones in a short amount of time. The only downside to the SkyWall technology is its relatively short range. The net can only reach targets up to 100 meters away from the launcher, which might already be too close if the drone is armed with medium-range weapons. However, longer-range applications are already being designed, especially for military and national security applications. As drones evolve, and become a more significant threat inside and outside the battlefield. Cheap and highly mobile technology like the SkyWall 100 promises to keep up with the rising threat by providing a robust and safe solution to keep the skies clear from danger. The Self-Protect High-Energy Laser Demonstrator, or SHIELD, is not only a directed energy weapons development program, but the U.S. Air Force's unique take on the potential of laser guns. Intending to demonstrate what a laser system can achieve when mounted on aircraft, the Air Service is already considering defensive lasers for bombers, but also for its existing fighters, such as the F-35 and F-22. Unlike its sister services on the ground and sea, the program will miniaturize the sheer power of lasers into small fighter-compatible pods. Should the endeavor fulfill its promise, the Air Force could integrate laser weapons for its 5th and 6th generation fighters sometime in the 2020s, kicking off a new era in air warfare. While it may be true that all branches of the U.S. military want to explore the use of laser weapons, they would all use them for distinct purposes. Even so, the unique way in which the Air Force is approaching the endeavor has drawn a lot of attention from experts in the field. The U.S. Air Force Research Laboratory submitted a request for information notice, announcing that they were on the lookout for market data about the development of podded laser weapon systems. The service is particularly interested in an electric weapon for its 5th and 6th generation fighters. However, such a device should be able to destroy incoming missiles, not merely dazzle them. So was born the Self-Protect High-Energy Laser Demonstrator, or SHIELD program. The effort's primary mission is to develop an advanced laser that could considerably surpass current capabilities and upgrade self-protection characteristics. The intention is for the laser to burn or otherwise disable infrared and radar-guided missiles at high speeds. To further complicate the matter, the program will follow a two-pronged approach. On the one hand, the Air Force plans to mount the lasers on the large AC-130 gunship, but on the other, they have to make sure they fit on smaller fighters too, such as the F-15E Strike Eagle. Notably, neither objective is even close to the concepts designed by the Army or Navy. Unlike their missile defense systems, the Air Force is first working on the development of a laser that can shoot down anti-aircraft weapons. Eventually, however, it should be able to attack flying and ground targets indistinctly. The Air Service's challenge is unquestionably more complex than the other efforts in terms of the technical hurdles and the tactical applications. Like future warfare expert Mike Gunzinger says, quote, "They're trying to do the hardest thing first." The Marine Corps, Army, and Navy's lasers are tactically defensive. Designed to shoot down incoming artillery shells, rockets, and drones, the systems are a step toward the ultimate objective of developing a laser with enough power and range to stop ballistic and cruise missiles on their track and protect bases, ground units, or naval task forces. Unsurprisingly, the Air Force has a little more aggressive vision. At the Directed Energy Conference, the head of Air Force Special Operations Command, Lieutenant General Brad Heitold, expressed, quote, "My customer is the enemy. I deliver violence." Despite the considerable firepower of the 105mm cannon on the AC-130 gunships, Heitold considered that a weapon with the unparalleled precision of a laser, complemented by the capability to dial energy up and down to fine-tune the level of destructiveness, would be a welcome addition to his fleet's current armament. Today, it is estimated that the AIM-120 AMRAAM air-to-air missiles reach a speed of roughly 3,000 miles per hour, although the exact figure is classified. Regardless, the laser is only limited by the speed of light and can travel at an unmatched speed of 186 miles per second. Vice Chief of Air Combat Command, Major General Jerry Harris, shared Heitold's opinion, arguing that, quote, "Directed energy gives you that opportunity to be much more lethal. Right now, when we talk about an air-to-air engagement, we measure it in miles and minutes. With directed energy, you change that to milliseconds." When boiled down to technical requirements, It's easier to fit a laser weapon in a spacious place, whether it's a ground base, a Navy ship, or even an Army truck. Even so, difficulties arise when trying to fit an intricate system like a laser gun in an airplane, let alone one as tiny as a fighter. Moreover, every ounce counts when it comes to fighter aircraft. Not for nothing, the world's first operational laser weapon was installed aboard a nearly 17,000-ton ship, USS Ponce. In contrast, the AC-130J weighs 82 tons fully loaded, while the F-15E doesn't weigh half as much. For all that, the Air Force considers that the potential benefits far surpass the challenges. For one, a laser doesn't run out of ammunition, except when deprived of electrical power. But a single gallon of gas can power a series of blasts, eliminating the limit for a half a dozen load of supersonic missiles. Instead, a fighter could carry hundreds of shots. Even more important, the aircraft could then rendezvous with an aerial refueling tanker to reload its weapons without the need to land. Lasers can fire an unlimited number of shots, and at the speed of light, they are an unparalleled measure to counter high-speed threats. Their inherent defensive value is not at all dismissed by the Air Force, but the Air Service's perspective regarding defense is narrower than that of the other branches. Admittedly, aircraft are already equipped with low-power infrared lasers, such as DIRCM and LAIRCM. These systems can blind several types of heat-seeking missiles, but not those guided by radar. While the Army and Navy would strive to protect a ship, base, or fleet, the Air Force is focused on self-protection. Or in other words, the individual aircraft carrying the laser. It is expected that the multi-purpose weapon could double as an offensive and defensive tool, ranging from low power mode for self-defense and the ability to dial up to a non-lethal offensive mode, such as burning sensors or engines. Evidently, it would be pushed to the limit. Brad Heitold added that he, quote, used to think offensive first and foremost. But the industry itself convinced him of the possibilities, like how the same laser gun can be deployed in defense or offense, depending on the power applied. Harris added that, quote, directed energy can be used against weapons coming at us, but also used to go after the shooter. In the near future, lasers may not yet hold the raw power to blow enemy aircraft out of the sky, as seen in the movies, but it is feasible that they can damage vital components. As a former Air Force pilot, Gunzinger explained that, quote, it is possible in the near term to develop and field the next generation of laser defenses that will burn out, not just blind, sensors on SAMs, surface-to-air missiles, and air-to-air missiles. Laser guns would be particularly effective against advanced missiles, which are equipped with sensitive multi-mode sensors. It is possible that in the next 5 years, aircraft will be armed with 150-plus kilowatt lasers, beginning with gunships and bombers. Even so, the Air Force's main focus remains on fighters, which implies a tighter fit. In turn, the Air Force Research Laboratory has planned 3 phases. First, SHIELD, a defensive system with tens of kilowatts of power. Then, a long-range defensive system that can reach 100 kilowatts. And finally, a 300 kilowatt offensive weapon that can blast enemy aircraft and ground targets at long range. Notably, the systems will be integrated into pods or other external add-ons, and not quite fully integrated weapons inside the airframe like other guns. As such, they will be fitted to existing aircraft. On the downside, fighters like the F-35 and F-22 with radar-evading technologies will have to sacrifice stealth to mount the laser guns. However, it will most probably take decades to see the full manifestation of destructive laser guns in action.